Now moving to a new section, capacitor, capacity. Capacity. What actually it means? Capacity. See, I will try to explain it with an example. Let me say one law. You can call it my law for water pouring. Okay. And the law is like this. After so many observations, I made it to a conclusion. You may be asking, what was your conclusion, sir? You take a pot and pour water to it. What I found is the level of the water start to rise. Right? So the level up to which the water rises is directly proportional to amount of the water poured. If I say such a law, you will be laughing at me, right? What rubbish you are saying, sir. Anyone can understand it is true. When you pour more and more water to it, its level will increase. It's a simple thing to understand what is science in it, what is that big thing to observe in it. It's quite natural, just quite natural. I will say one another thing. You take a conductor, let us take it as in the case of a spherical conductor. You take the spherical conductor. Any conductor you can take, right? Just now I am taking a spherical conductor. You give charge to it. What happens? The charge is keep on depositing over the surface. Quite naturally, it will rise its potential. It will rise its potential level. So the potential up to which it is raised is directly proportional to the amount of charge given to it. Just like the level up to which the water rises is directly proportional to the amount of water poured in it, just like that, the potential up to which it rises is directly proportional to amount of charge given to it. And for any conductor, if you take Q by V, the ratio, that ratio will be a constant. For any conductor, the charge given to the conductor and the potential up to which it is raised. I will repeat, for any conductor, the charge given to the conductor and the potential up to which it is raised, the ratio is a constant, and that ratio is known as capacity or capacitance. That ratio is known as capacity or capacitance. Now if you give large charge, okay, even after that its potential rises very small. What it means? Large charge you give, potential rises by very small, this ratio will be very high value. You got it? Even if you give small charge to it, its potential rises very large, this ratio will be very less. So large charge you can give, the C will be more. So more C, more charge you can give. So that's why we say the ratio C is the ability, is the measure of the ability to store charges for the conductor. So capacity is the measure of the ability of the conductor to store charges. Q by V is a constant. And that constant is the measure of the ability to store charges. That constant is the measure of ability to store charges. And this is Coulomb divided by volt, and we call it as Farad. And it's otherwise represented by the symbol F. This is what the capacity is. What actually capacity is. Now, let us try it for spherical conductor. Ready? For spherical conductor, what happens to the capacity? Spherical condenser, what happens to the capacity? Now I told you, see, you are giving Q charge to it. So charge given is equal to Q. Potential up to which it is raised. Potential up to which it is raised is equal to, I told you in previous class, the potential at the surface was 1 by 4 pi epsilon 0 Q by R. Okay, 1 by 4 pi epsilon 0 q by r. So the potential up to which it is raised is 1 by 4 pi epsilon 0 q by r. Now capacity is the ratio of charge given and potential up to which it is raised. That will be equal to q divided by 1 by 4 pi epsilon 0 q by r. So q and q will be cancelled. It will be equal to 4 pi epsilon 0 r. Okay, so capacity is equal to 4 pi epsilon 0 into r. And do remember 1 by 4 pi epsilon 0 was 9 into 10 raised to 9. So it will be 1 by 9 into 10 raised to 9 r. That much farad. So capacity is equal to 4 pi epsilon 0 r farad, I should say. Now in CGS, the capacity value will be equal to radius in centimeter itself. So in CGS unit, the capacity value will be numerically equal to the value of the radius itself. Okay, so this is what the capacity is, capacity or capacitance, which is actually the measure of the ability of the conductor to store charges. More capacity means more charge it can store. And capacity is nothing but the ratio of charge given to the conductor and the potential up to which it is raised. Okay. Now next we will move on to find the capacity of different types of distribution of conductors, different types of conductors. And we will study about capacitor. What is capacitor? I told you capacity now. And capacity is there for every conductors. For every conductors it have got a capacity. Now what is a capacitor? That we will see in the next class. Okay. Thank you.